Okay, Assalamualaikum and a very good afternoon. So today we are going to discuss an example for the continuous time signal and also the discrete time signal. Let's look at the first question. The input signal of a complete linear time invariant system is given as G1. Okay, you need to write the mathematical expression, meaning the equation for the signal in ramp function. Okay, you need to revise back the basic information on the type of signal and also its mathematical equation. So if you have this type of signal, so you know it is UT function. Okay, the amplitude is 1 and it happened across the t values. Okay, if you have a ramp or the line width gradient, so this is the ramp function, ramp t, in which ramp t can also be represented in unit step function. Okay, this is unit step. And this is the ramp function. So ramp t is equal to t u t. Okay, so in this question, you need to write down the G1 equation in ramp function. Okay, so you need to convert this equation into a ramp function. Which one can be ramp? If it is not ramp, then it will stay in UT or unit step equation. Okay, next you need to sketch G1t. Okay, to solve a problem, you need to look at the total marks given. Okay, 3 marks, so meaning that you need to have the steps. If only 1 marks, meaning that you can just simply write your final answer. But if you have more than 1 marks, meaning that you need to show clearly the steps in order to solve the problems. Okay, especially in the second one, 5 marks. Although from the equation you can basically illustrate how the signal looks like. However, since you are about to have 5 marks, meaning that you need to have complete steps in order to before you can achieve your final answer. If you only give me the final answer, for example, G1t, you got something like this. So you only get maximum of 1 to 2 marks only. You will miss the 3 marks for the steps. Okay. Okay, let's look at the first question. Don't forget to write down the question number and also the sub-question number. So this is question 1 and it is part A. So the question asks you to write down the mathematical expression or equation for signal G1t in ramp function. Right, so let's revise back what is ramp function. So this is how the signal looks like. So this is basically ramp t. So ramp t is basically equal to t u t, in which if you have t in front of the u, so it is basically representing a ramp function. And usually the t is written having the same parameters or values as the values inside the bracket. For example, if you have ramped t minus 3 and it is equal to t minus 3 u t minus 3. You can see the same or the repetition of the same equation in the bracket with the function in front of the u. If you have the magnitude in front of the ramp, for example 2, don't forget to write down the amplitude as well. Okay, so for the given question, you need to write down or to convert the given equation into ramp function. So you need to show your steps because you need to address that 3 marks. Right, so the first step is to identify which component basically representing the ramp function. Right, so the one that have t in front of the u is basically the ramp function. So this is not the ramp function, however you still need to include that into the equation so that it gives you the complete signal. So this is the first ramp, you have t, and then you have the second one here, and then you have the third one, and lastly here there's no t in front of the u, so it is not a ramp function. Right, so to solve this, so for the first component it is t minus 1 u t minus 1, so this is equal to ramp t minus 1. And for the second component, it's 2t minus 2 u t minus 2. It is equal to 2 ramp t minus 2. And for the third component, it's t minus 3 u t minus 3. It is equal to ramp t minus 3. Okay, finally, you need to rewrite the given equation, including the ramp function. Okay, because not all components are in ramp, because you have here not a ramp function, it is a unit step function, so you just need to include them all in your equation. Therefore, your g1t is equal to ut minus the first component in ramp, so it's ramp t minus 1, and then plus the second component with amplitude of 2 ramp t minus 2, and then minus again the third component, it's t, so in ramp function it's ramp t minus 3, and then lastly minus the unit step function ut minus 5. So this is your answer for 3 marks. Okay, if you only show this equation to me without this step, so you may get only 1 marks for the final answer without the steps, alright, without 2 marks for the steps. Okay, now let's move on to the second part of the first question. So don't forget to write down the question number in your answer script. So 1 part B, so you need to sketch G1T. Okay, G1T is given as the following equation, and you need to address, or you need to show steps to address that, 5 marks. Right, so as shown in the lecture notes, so to sketch a signal, I would recommend you to use the method that I've shared. So it will be much easier for you to trace, okay, part by part. On the other hand, you can also use manual sketching, in which you can have a different sketching for each component, and then you perform the mathematical addition or subtraction. Okay, however, I found it a bit difficult if you sketch that in not similar axis, so you may have problems with the magnitude at certain point, and etc. Right, so let's use the method I've shared. If you prefer, if you want to use the other method, that you may proceed. There's no problem with it, as long as you show the steps in order to solve the problems. Right, so the first step is to determine how many components you have in the equation. So in this case, you have the first one, ut, and then you have the second one, this one. This is the second component, and then you have the third component here, and next you have the fourth one, and lastly you have the fifth one. Okay, so next step is to determine the range of t. Right, so begin with the first component. It is equal to ut. You don't have to write down the operation first, just get the main component, okay, with the magnitude. Right, so ut, so in this case, the range of t, it will be always 0 and maximum magnitude. Alright, so here 0 and maximum magnitude here is 1. So for the range of t, in this case, you need to compare this one, the t, with t minus something like t naught. right? So t naught in this case is 0. So t minus 0. So the range of t is from 0 magnitude for t is less than 0 and 1 magnitude for t larger than 0. Okay, next, consider the second component. So I should use the same color as the component number. So second component, just get the main component without the operation. So it's t minus 1 u t minus 1. So this is, okay, again, the 0 and the maximum magnitude. So the maximum magnitude is any values in front of the u. So in this case, it's t minus 1. T minus 1. So how about the range? So compare with the one in the bracket, it's t minus, okay, basic shifting is t minus positive 1. So the ratio is between t less than positive 1 and t larger than positive 1. Okay, and next, the third component, it's 2t minus 2 u t minus 2, right? It's equal to, from 0 to the maximum, it's 2t minus 2, and the range is, again, t minus positive 2, so it's t less than 2 and t larger than 2. And the fourth component, t minus 3 u t minus 3. So what is it? So it's from 0 up to the maximum of t minus 3, and the range is t less than 3 and t larger than 3. And finally, the fifth component, okay, is u t minus 5, right? So 0 until the maximum magnitude of 1. So the range of t is less than 5 and t larger than 5. Okay, once you have all this range, you need to perform the summation between the components considering the range of t, right? So the range of t will increase from the first step up to the final step, right? So in this case, let's look at the main equation again. So it's g1t. To get g1t, so you have the first component will be subtracted by the second component, and then plus the third component, okay, and then minus the fourth component, and then minus again the fifth component, and will give you the total, right? So let's determine the range of t. The first one, the minimum one, okay, the least one is when t less than 0. Okay, at t less than 0, look at the component 1 magnitude. T less than 0, the component 1 magnitude is 0. Okay, how about the t less than 0 for second component? Any value less than 1, always 0. Same goes to the third, fourth, and fifth component. So in this case, all zeros. And don't forget the signpost or the operation. So it will give you a total of 0. And now let's increase the range. So before this, it is t less than 0. Now it will be t larger than 0, but less than the next range. The next range is 1. Okay, so it's t larger than 0, but less than 1. So what happened to the first component? If t now is larger than 0, okay, the magnitude become 1. And then how about the second component? When t is larger than 0 but less than 1, okay? For second component, when it is less than 1, the magnitude is still 0. So 0. And the third component, any values less than 1, always 0. Same goes to the third, fourth, and fifth, right? So 0, 0, 0. Don't forget the operation, plus, minus, minus. So you got 1. Okay, now next, increase your range of t. Before this is less than 1, now it become larger than 1. T larger than 1, but less than the next range. The next range is 2. Okay, look at the first component when it is larger than 1. Okay, larger than 1, so meaning larger than 0, always 1. Second component larger than 1, you got t minus 1. Okay, and then the third component larger than 1 but less than 2. Less than 2, always 0. Same goes to the fourth and the fifth. Okay, you can see the trend that once the range is increased, so the component that having magnitude also increase. Plus, minus, minus. So sum them up for the total. So 1 minus t minus 1. So 1 plus 1 is 2 minus t. Okay, let's move on to the next range. Let's use different color. So now, before this is t less than 2, now it becomes t larger than 2, but less than the next range is 3. Alright, look at the first component. So larger than 2, always 1. Okay, larger than 2, always t minus 1. And then the third component is now larger than 2. Larger than 2, you have the magnitude of 2t minus 2. So 2t minus 2. Right, the fourth component, t less than 3, always 0 and 0. Okay, so sum them up. So it's basically 2 minus t, and then plus this component, plus 2t minus 2. Okay, it's 2 minus t plus 2t minus 4. So you should get 2 minus 4 is minus 2. Negative 2 plus 2t is plus t. So it's t plus 3 minus 2. Right, let's move on to the next range. It's t now larger than 3, but less than the next range is 5. Right, so 1 minus t minus 1 plus 2t minus 2 minus, okay, the fourth component when t larger than 3. Larger than 3 is t minus 3. It's t minus 3 minus the fourth component when t is less than 5, always 0. So sum them up. So it's basically t minus 2. Okay, basically you can sum them all from here, but since we have calculated up to this point before this, so we just need to consider this component by considering the upper range total. Right, so t minus 2 minus the new component is t minus 3. So it's basically t minus 2 minus t plus 3. So it's basically 0 and 1. Okay, lastly, you have the maximum range of t larger than 5. Okay, so you have all the components in t minus 1 plus 2 t minus 2 minus t minus 3 minus the last component magnitude when it is larger than 5 is 1. Okay, so it's 1 plus minus 1, it's 0. So now you already have all the total. So lastly, you need to plot the magnitude based on the range of t. Okay, from the earlier step, what we have had is g1t equal to, we have the ratio, the range of t when t is less than, okay, the magnitude, the total is 0. Okay, the total is 0 for t is less than 0, and then for t is larger than 0 and less than 1, and then t larger than 1, less than 2. Next is t larger than 2 but less than 3. Next, t larger than 3 but less than 5. And lastly, t larger than 5. So you need to simplify or summarize them to ease your plot. If you have the answer in the same page, should be okay. So for the second range, 0 to 1, the magnitude is 1. So 1 to 2 is 2 minus t. 2 to 3 is t minus 2. Oops. And then 3 to 5, you have 1, and lastly you have 0. So now you can plot the signal based on the duration of t. Right, so let's have the axis first. Oops. Okay, sorry for my handwriting, also my sketching. Okay, so let's have your axis, and then your limit is t is all positive values beginning from 0. So you can only have the right hand side. So the range of t is from 0, 1, 2, 3, and then lastly 5. Okay, don't forget to label them. Right, so this one is your G1t. Right, so from t less than 0, the magnitude always 0. Okay, this is for t less than 0. Always 0. And then t from 0 to 1, the magnitude is 1. Here, 0 to 1, magnitude is 1. Okay, and then from 1 to 2 is 2 minus t. Right, so 1 to 2 at this point. 2 minus 3, how to plot that? So you can put in your t values to ease your drawing. Right, so when t equal to 1, so the magnitude is 1 at this point. When t equal to 2, it's 0 at this point. So this is from 1 to 2. And then from 2 to 3 is t minus 2. Again, put the t equal to 2. So it is 0. And then when t equal to 3 is 1. Okay. Right, fine. Next is from 3 to 5. Okay, so the magnitude is constant 1. Okay, lastly, when it is larger than 5, it is 0. Okay, so then you just join them. Okay, very poor freehand sketching. Sorry for this. Right, so this is basically your G1T signal, how the G1T signal looks like, right, from the given equation, right? So next, in order to ensure that you can write down the equation back, so you can derive back the equation by considering the same signal, so to make sure you get the same equation back. All right, thank you. Let's proceed with the next example. Okay, let's move on to question number 2. It's consider the given signal ft in time domain. So write the signal using a single analytical expression with the aid of a unit step ut and ramp function. Right, so you need to write down the mathematical equation for the given signal in both unit step and also ramp function, and you should address 4 marks. All right, meaning that you need to show the steps. Although from the given picture you can straight away identify what's the equation is. However, in order to get full mark of 4, so you need to write down the steps in between before you can get the final answer or the final equation of ft. And next, question 2b, you need to plot the new signal based on the given equation f3 minus 2t. Okay, let's look at the second question, part A. So consider the given signal. You need to write down the equation. So in order to write down the equation, as I've shown you in the lecture notes, you need to consider the lines intersecting between the t. okay, t values. So, and then determine how many lines basically crossing that point. All right, so let's begin with the first point, usually the left hand side. So we will start with t equal to the least one, or the last, the minimum one is t is equal to -2. Okay, t equal to, don't forget to write down the question number, yeah, so 2a. All right, so t equal to -2. So look at how many lines connecting at point t equal to -2. So you have this line, okay, and it's pointing up from this point, from this t equal to -2. So you have only one arcoid slope, okay, the line with gradient. So then you don't have any other lines crossing this point, so only one slope. So then you need to consider, since it's going up, so you have positive sign, and then followed by the gradient. The gradient, okay, the gradient, we can say 2 over 2 y over x, followed by the equation is t minus, okay, remember the shifting equation always t minus t naught. So in this case you have t minus t naught. Your t naught is -2. Okay, so it becomes t plus 2. T plus 2 u t plus 2. Okay, so this is the first t. So next t, you go forward. So next t, you have t equal to 0. So at t equal to 0, so look at how many lines you have. Okay, only consider vertical lines and also the one with slope or with gradient or the ramp. You don't have to consider the horizontal line. All right, so in this case at t equal to 0, so how many lines connecting? How many vertical lines and also the slope connecting at point 2, at point t equal to 0. So it's this one. At this point you have these lines. Okay, from t equal to 0 it's pointing down. Okay, from this point, from t equal to 0, it's pointing down. So you have one slope and it's pointing down, negative. And another one, you have again a vertical line. Okay, vertical line, and it's pointing down as well. Okay, and you have another one, you have one straight line or vertical line, and it's pointing down as well. All right, so for vertical line, for example, if you have this graph, how to determine the positive or negative sign, you use the flow. Right, so look at from the left hand side. So this one is going up and then going up again, going down and going down. So this one will be positive, positive, negative, negative, based on the flow. Okay, it's positive increasing and negative for decreasing. Right, so for one slope at t equal to 0, so you have this line pointing down. So the gradient is the same as the earlier one. So 2 over 2 or 1 over 1, depending on which cross section you took. And then in this case is the slope, so you know it must be t minus t naught. So in this case the t naught is the position of 0, so it's t minus 0. You can write it down or you can just leave it as t. Okay, u t minus 0. And then you have the second line is the vertical line, so you don't have to, the equation should not include t in front of the u. So in this case, if you have vertical line, you just need to consider the magnitude. Okay, in this case the magnitude from 2 to 1, so the magnitude is 1, so it's negative sign 1 followed by u and then the position, so t minus t naught. In this case t naught is 0. So in this case you have two lines crossing at t equal to 0. Okay, next proceed with the next point. You have t equal to 1. So t equal to 1, look at how many lines you have, vertical lines. Okay, so for the flow, so from here and then here is go down again. All right, so you only have one line and is pointing down, the magnitude is 1. Okay, so ut minus t naught. Your t naught is positive 1. Alright, so this is the final component, a final t and final component. You don't have second line or slope crossing at 1. Alright, so finally you need to sum them up. So in this case, your ft is equal to, start with the first component up there, so it's positive. 2 over 2 is 1, so it's t plus 2 ut plus 2, and then followed by the second component, you have negative. So negative 2 over 2 is 1. You can write 1 if you want. And then t ut. Alright, so we have done this and this. Next is minus 1 ut. Okay, you have done this as well. And finally, you have the final component. It's negative ut minus 1. So this is your ft. Okay, however, don't forget to read again the question completely. So write down the equation in unit step and ramp function. Okay, the one that you produce here is in unit step function. So you need to rewrite it back considering the ramp function as well. So again, identify the component that you have in ramp function. So in this case, you have here and this one. You have two components with ramp function. So it's t minus positive 2 ut plus 2. So this is equal to ramp t plus 2. And then the other one is t ut. So this is equal to ramp t. Therefore, your ft is equal to ramp t plus 2 minus ramp t minus ut minus ut minus 1. If you've done this way, you will get straight away 4 marks in total. Okay, next let's move on to question 2b. Right, so don't forget to write down the question number. Okay, I keep on repeating the same statement again and again, and please make sure you do this in your test and also final exam and also in any exercises. Question 2b. Right, so plot f3 minus 2t. Alright, so in order to plot a signal, you cannot simply straight away plot this signal. Okay, because it involves more than one operations. Okay, you have I've shared 3 methods in the lecture notes. However, I would prefer you to use method 3 because it is so organized so that you can easily keep track on the progression or the conversion. Right, so in this case, consider method 3. If you don't know what is method 3, go back and review back again the lecture notes. Method 3. Right, so the first step in method 3, you need to consider the component inside the bracket. Right, so in this case, you don't have any magnitude or amplitude operation, you only have time-based operation. Anything happen inside the bracket is basically time-based operation, and outside the bracket in front of the equation is basically the amplitude-based operation. If you have amplitude-based operation, any values for amplitude-based operation here, so you can simply multiply or reverse, inverse, or scaling, and then shifting, okay, and etc. It's quite easy. See, I would recommend you to solve the time-based operation first inside the bracket. So the first step is represent any equation inside the bracket using tau. So in this case, tau equal to 3 to t. And then find the t. Right, so next t equal to tau minus 3 divided by minus 2. Okay, Next, what is the tau value? Tau value comes from the signal itself, the given signal, right? So redraw the given signal, but then change the axis to tau, right? So you have the same signal. Right, so now t become tau. So here is f tau, and then the magnitude is the same, the t also, the tau also, the value is also the same, -2, 0, and 1. Okay, now you need to determine the t new, okay, t new based on the tau values, all right? So beginning at the left hand side, so for tau equal to -2, so for tau equal to -2, what is the t? So t is equal to, that tau is -2, -3 divided by -2, -5 -2 is 2.5. Okay, next, move on to the next tau. So the next tau is 0. So for tau equal to 0, so your t is equal to 0 -3 divided by -2, -3 -2, 1.5. Okay, next tau, the third tau, you have 1. So tau equal to 1. So the new t is 1 -3 divided by -2. Okay, from this equation that we derive from the component inside the bracket, okay, from here. All right, so 1 -3 is -2, -2 is 1. Okay, now let's apply all these tau values into the graph. Okay, copying the same axis, now it becomes t new. All right, so check with tau. When tau equal to 2, tau equal to -2, so the new t is 2.5. Now it is 2.5. When tau equal to 0, the new t is 1.5. Okay, when tau equal to 1, and the new t is 1. Okay, now copy the same shape of the signal into the new t-axis. So just copy the same position, the same magnitude, but on new t-axis. This shape, something like this, and then like that. Okay, magnitude is still 2, and here is still 1. Whoops. Okay, this is the new shape. Okay, however, if you look at the axis, it's on the left hand side, 1 to positive 2.5. Okay, so you need to reorder it back considering normal orientation of the axis. So now you may have, you need to flip the axis, okay, to there, right? So it become, so it's something like mirror. Okay, here is your 0.0 position, so it's just like mirror image, right? So you'll have this one and then go up there. Sorry, and should go up here and then go down. Okay, so this one is at 1, and then 1.5, and then 2.5. Don't forget to label the t-axis, right? So the magnitude, so now this is the signal for f3 minus 2t, and it is magnitude, the magnitude is 1 and also 2. Okay, so this is your graph for f3 minus 2t, and you'll get 5 marks if you done all these steps completely. Okay, let's move on to the third example. So a discrete signal as shown in figure Q3C. Okay, so from this figure, you need to write down the mathematical expression for signal xn. Alright, so the xn representing the discrete position or discrete signal. So you need to revise back if you have only one point. This is known as unit impulse, and the equation is del the n position, right? And depending on its position here, it's beginning from 0 up to n. So again, you need to consider the shifting position. All right, so here in n minus 1. Why n minus 1? Because shifting position rules is n minus n naught. So n minus, in this case, positive n naught. Okay, you have positive n naught on the right hand side. Right, if you have only one unit impulse, so it is represented by delta function. But if you have a series of impulses, all right, with the same magnitude, 1 up to infinity, and n domain, so this is called the unit impulse function, un, okay, or unit step function for n domain. All right, so if you have only single at certain position, you should represent it with delta function. All right, so in this case, so let's look at the signal you have. So it's basically you have multiple impulses at different positions, so you need to consider writing your equation in delta n function. Right, so let's look at the first. So the max is 2. So as long as it's quite simple, as long as you can identify the position, so you can write the equation straight away. So in this case, your xn, so you have start from the left hand side. So you have the magnitude of 0 at n equal to minus 2, and then so you don't have to write it because the magnitude is 0. So at the one that have amplitude is here, its magnitude is minus 2, and then delta and minus 1, okay, because it's at the position of n equal to minus 1, and then plus the magnitude of 4, and again delta function for n minus n naught is 0 in this case. Right, next you have a negative 4, and then delta, and its position is n minus positive 1, and then you have 0 here, magnitude, and also here, so you have another one here, it's positive 4 delta and minus positive 3, and then finalize your equation. So your xn is equal to minus 2 delta n plus 1 minus plus 4 delta n minus 4 delta n minus 1, and then plus 4 delta n minus 3. So this is your equation for signal xn. So you can get 2 marks out of this equation. Okay, the final question in the example is question 3b. Don't forget to write down the question number 3b. Right, so sketch fn. Okay, given xn, so you need to sketch a new signal given by fn equal to negative 2x 0.5 n minus 1. So meaning that something happened to the original signal Sn by using this function, so that it will produce fn. So again, if you have signal operation, you need to use, or you may use method 3 in order to sketch a signal. Okay, so let's begin with the first step. You need to identify the component inside the bracket and then represent that as tau. So fn equal to negative 2 x 0.5 n minus 1. So let's look at the what happened to the signal. You have scaling, and then you have shifting, and then you have amplitude inversion and also amplitude scaling. Okay, so you need I'll recommend you to to solve the time-based operation first inside the bracket. So now represent the one inside the bracket as tau. So tau equal to 0.5 n minus 1. So what is your new n? New n equal to tau plus 1 divided by 0.5. Okay, so also equal to 2 tau plus 1. So what is your tau? Tau is basically the value of n that being converted into tau. Okay, so let's draw that signal again. So now the axis n becomes tau, right? So it's here, -2, -1, 0, 1, 2, 3, and 4. And in a discrete signal, it's very important to arrange your signal sequentially, okay, to so that the end position is aligned to the next graph, because it will be easy to multiply or to add or to subtract them, because all operations you need to do considering the same end value. Okay, if it is at 1, so the subtraction must be done at 1 as well. Right, so for the given signal, at 2 is 0, and then at 1 it's -2, and then it's 4 at 0, and then it's -4. It's -4 at 1, and then 0 again, and then +4 again, and 0 again. Right, so change the n to tau. So now consider the tau values into to determine the new end position. Okay, so when tau equal to, although the magnitude is 0, so you still need to consider, because based on the calculation, you may have magnitude in the new end axis. Right, so when tau equal to -2, so your new n equal to 2 plus 1, 3, 6. Right, so tau next is tau equal to -1. It's n equal to 2 minus 1 plus 1 equal to 0. When tau equal to 1, n equal to 2, 1 plus 1 is 2, 2, 4. Is this correct? Sorry, it's -2. -2 plus 1 is -1, -1, -2. It's -2 here. Alright, so tau equal to +2, and then it's 2, 2 plus 1, 3, 2, 6. Tau equal to 3, n equal to 2, 3 plus 1, 3, 1, 4, 8. And then tau equal to 4. It is n equal to 2, 4 plus 1, so 5, 10. Right? So now you already have your new end axis values. Alright, so now use the new end axis. So when tau equal to -2, it becomes -2. When tau equal to -1 is 0. When tau equal to 0 is 4. When tau equal to 1, it is 4. Sorry, -1. Is this? Am I doing it right? Let me consider again. So tau equal to 0. So n equal to 2, 0 plus 1. Okay, so it's 2. Okay, here it's 2. Okay, -2, and then 0, and then 2. When it is 1, it is 4. Okay, look at this. I try to align them accordingly in the same arrangement. When 2, it is 6, and it is 3, 8, and 4 is 10. Okay, again, redraw the same magnitude on the new end axis. So it's 0 here, and then here it's -2, and then you have 4 here, and then you have minus 4, and then you have 0, and you have 4 here again, and then here. Okay, so now this is the function for the one in the bracket, fn equal to 0.5, x, so I should use bigger space. Okay, so this is the function for fn equal to x 0.5 and minus 1. You haven't done the amplitude part, sorry, -2 part, right? So in order to get the fn equal to minus 2x 0.5 and minus 1, so you need to multiply the amplitude with minus 2. So all this amplitude need to be multiplied by minus 2. Alright, so you need, meaning that the amplitude will be inverse and will be, the magnitude will be scaled up by 2. Right, so in this case, the same position and the arrangement is okay. You start with negative values up to the maximum positive values, so you can just simply copy the position, -2, and then 0, 2, 4, 6, 8, and 10. Okay, right, so okay, let's consider the first one. The magnitude is 0, so multiply with -2 is still 0, and then the second one at n equal to 0, so the magnitude is -2, multiply with -2 is +4, and at 2 it is 4, multiply with -2 is -8. Right, at 4 it's -4, multiply with -2 is +8. Okay, please draw this accordingly, but due to this limitation, so I just put the magnitude as 8 here. Okay, at 6 is 0, and at 10 also 0, and then at 8 is 4, multiply with -2 is -8. Okay, so this is the final answer for f for the given function, f equal to -2x multiplied with 0.5 and minus 1. Okay, so this is the y-axis. So this is your final answer in order to get the full 3 marks. Okay, with that, thank you. Perhaps you this may improve your understanding on the basic operation of signal.